Hello again. Thanks for watching this video and studying your math. Remember to read your book because the examples are different there, and to play, pause, and rewind this video to get the full advantage of it. We're going to be doing partial fraction decomposition. An analogy is useful. In the same way that we can take a pair of binomials and multiply them together using a technique called foiling to get a trinomial, we also learned that it was important to take the trinomial, factor it to decompose it into the pair of binomials. That's what we're actually doing here. We take a simplified rational expression and we break it into the fractions that will comprise it. This is important in calculus. This is the only way you can do some calculus problems. The discussion in your book, shown here, some students find awkward and prefer mine. Partial fractions can only be done if the degree of the numerator is strictly less than the degree of the denominator. If that isn't the case, you must do long division first. Once you've put it into that form, what you do is factor the denominator as completely as possible. And then for each factor in the denominator, use the following table to determine the terms we pick up in the partial fraction decomposition. So every term, every factor of the form ax plus b, where a and b are constants, generates a term in the partial fraction decomposition of capital A, another constant, over ax plus b. If that's raised to a multiplicity k, it generates k terms. Notice that a1, a2, up through ak are different constants. If you cannot factor it, we call this an irreducible quadratic form, and you generate a term that looks like this. Again, the capital A and capital B are constants, but now you have an x, and if this is raised to the multiplicity k, we get k terms that look like this. Examples will make this much clearer. Here's the first example. Pause the video now. Let's see how you did. First we do long division, and we get 3x plus, and this is the term where the degree of the numerator is strictly less than the degree of the denominator. So we will do partial fraction decomposition on this. So we factor the denominator, and we get two linear factors, x and x minus 1. So I look at ax over plus b over x minus 1. We simplify that, and then we equate the numerators. So we have 7x minus 4 has to be the same as a plus b times x minus a. We equate the coefficients, solve the linear system, and we have this partial fraction decomposition. Pause the video now and do the problem. Let's see how you did. This time we have it raised to the third power, so we get a term that looks like this, a second term that looks like this, and a third term that looks like this. Now if I just get a common denominator, here's what the numerator will look like. The numerator will be a times this, plus b times that, plus c. And if I do some simplification, I get as my numerator ax squared. That means a has to correspond to the 1. Minus 6a plus b has to correspond to the minus 4. And the constant 9a minus 3b plus c has to correspond to the 7. I solve this system of equations, and I find out these are the values of a, b, and c, and that is my partial fraction decomposition. Pause the video now and do this problem. Let's see how you did. Here I have a linear factor and an irreducible quadratic factor. This has no real roots and cannot be factored. So I have a over x plus 4 and bx plus c over x squared plus 1. Again, I get a common denominator just like this one, and this is what I get for my numerator. And here's what my numerator is once I simplify it. So a plus b corresponds to the 8, 4b plus c corresponds to the 10, and a plus 4c corresponds to the minus 3. So I solve that linear system, and I end up with these answers, and this is my partial fraction decomposition. One more example. Pause the video, please. Let's see how you did. This one has the irreducible quadratic form raised to the second power. That means I get it raised to the first power and the second power in my partial fraction decomposition. Again, what I do is I get a common denominator, like this, expand everything, and collect type-like terms. So I have a plus b corresponds to the 1, c corresponds to the 3, 4a plus 2b plus d corresponds to the 4, 2c plus e corresponds to the 2, and 4a corresponds to the 4. So I have this system of linear equations to solve. I get this as an answer, and this is my partial fraction decomposition. And there is a summary in your book that I would pause and read this as a final learning aid. In closing, time is precious. Each day must count. Do the math. It will make you strong. See you in class.